next topic in the image restoration techniques via deep learning is image super resolution. So in image super resolution, the model try to enhance the resolution of an image to create a high resolution version from a low resolution input. So it will recover, the model will try to recover finer details, image clarity will also improve, and then the visual quality of the image also increases. So most of the common methods are interpolation, that are traditional based methods, and we have also used deep learning algorithms and as well as generative models. So image super resolution or video super resolution has been widely used in the field of medical imaging, satellite imagery, security surveillance, media enhancement, or such as video game super resolution that has been adopted in most of the well-known games. So after super resolution, it facilitates for better analysis and interpretation of image in various domains by providing clearer visuals. And here are some example for super resolutions output. So this bicubic is nothing but a bicubic interpolation. This is a traditional based super resolution method, but you will see that although the resolution of the image has increased, but the sharpness of the image, sharpness and the details of the actual object is not present. So this is one of the drawback of this traditional based algorithm, and you can see this in the GAN based, like in this here it's a real ESRGAN. This particular model is able to generate very high quality, high detailed, high resolution image from a low quality, low resolution image. And real ESRGAN, and SRGAN are some of the base architectures of image super resolution using deep learning techniques. Coming to image super resolution using generative adversarial network, there are certain challenges that it involves in super resolution using deeper or faster CNNs. The challenges are that one of the challenges are recovering fine texture details during like large scale upscaling, and then these methods are mostly focused on minimizing mean squared error. And although minimizing mean squared error will obviously leads to higher PSNR value of the reconstructed or super resolved images, but it necessarily does not mean that the perceptual quality is also high for that image. So SRGAN is the first framework capable of generating photorealistic image with up to 4 times upscaling factor. So in SRGAN, they have introduced a perceptual loss function that combines adversarial loss and then content loss. So coming to the network architecture of SRGAN, so here is the actual architecture of the SRGAN. So it's a adversarial network setup. So it utilizes a generator and a discriminator. So generator generates a realistic image to deceive the discriminator into classifying them as real, and discriminator differentiates between a super resolved image and a real image. In SRGAN, they have actually introduced perceptually superior solutions compared to traditional pixel wise error method like MSC. And the next architecture is ESRGAN, which is nothing but an enhanced SRGAN. So ESRGAN builds on the SRGAN framework to improve the quality of generated high resolution image, focusing on finer texture and realistic details. So what are the key modifications that ESRGAN has done on the SRGAN framework? So the first thing they have done is they have removed the batch normalization layers with residual dense block to enhance learning capabilities and reducing artifacts during training. And then they have also implemented a new perceptual loss function combining adversarial loss, content loss to improve the visual quality and the realism of the generated images. First key modification was the elimination of the batch normalization layers and then substituted by this RRDB block. So, by the removal of this batch normalization layers, ESRGAN was able to avoid artifacts that was very specific due to the batch normalization that was present in SRGAN. And then the RRDB block was leading to a more robust and deeper architecture with their dense connection, and it boosted the performance when compared to SRGAN. So, the overall performance of ESRGAN is that it has more stability and training improvements compared to SRGAN. So, they have actually introduced a network interpolation strategy where they try to strike a balance between the visual quality and the PSNR value. So, here is a demonstration. So, here alpha is the interpolating factor. So, the higher the alpha value, it will create a high visual quality image which are sharper and has finer details, but the PSNR value will be less, and then as the alpha value decreases and goes towards 0, the overall reconstructed or the super resolved image leans towards a higher PSNR value, but the overall visual quality is not that good, as we can see from here. So, this network interpolation strategy tries to strike a balance between these two ranges of perceptual driven or PSNR oriented. So, it should be somewhere in between this area. So, the alpha value ranging in the between 1 and 0 will actually give to a balanced reconstructed super resolved image where the visual quality is high as well as the PSNR value is also high. So, this is an animation of the interpolating strategy that they have adopted. Here you can see that as the alpha values increases from 0 to 1 towards 1, the blurry details in the images started to appear sharper, and the finer details are able to are actually reproduced in the super resolved images. So, the thing is, as the alpha value increases, the visual quality increases, but we have to keep in mind that the PSNR value also decreases. So, we have to strike a balance between this PSNR value and the visual quality. So, in order to implement this super resolution model, we will clone the GitHub repo of ESRGAN. Once we have cloned this ESRGAN repo, we will go to the root folder, and then inside the root folder we will also download the pre-trained model that is available, and then place it in their respective directories. Once it is completed, we will provide our own low resolution images in the LR folder, and once the low resolution images are present in the LR folder, we can test the model on these images. So, here for now I have given only 3 low resolution images, namely baboon, video game and comic. So, let's try running on these 3 low resolution images. And I will show you the output visually also. So, this is a very low resolution image of baboon, and this is the resolution of comic, and this is a low resolution of video game. image. So after running through the passing it through the model, so this is the high resolution that is scaled up to 4 times. So this is the input image and this is the output image, and similarly this is the input image and this is the output image.